3D bioprinting is one of the most revolutionizing and emerging fields of the 21st century. In this video, we will learn about the origin of 3D bioprinting technology and how it evolved with time. This technology has hugely disrupted the domain of healthcare and medicine. Back in May 1980, Hideo Kodama from Nagoya Municipal Industrial Research Institute, Japan, was the first to come up with the concept of layer-by-layer manufacturing. His technology enabled the development of a rapid prototyping technique. It used UV light to cure the photosensitive resin to obtain a three-dimensional model corresponding to the sliced computer-aided design. Unfortunately, due to funding issues, he could not complete his patent filing within the given period, because of which he lost his title of an inventor. 4 years later, in 1984, Charles Hull developed the first ever 3D printer and patented the technology, which is now commonly known as SLA, or stereolithography apparatus. Hence, Charles Hull is now unanimously considered as the father of 3D printing. The ever-broadening spectrum of applications using this technology led to the invention of bioprinting. Researchers at Wake Forest University came up with the concept of using cells along with different hydrogel material as bio-ink to print the desired synthetic organ. At the beginning of the 21st century, researchers took a step ahead and printed scaffolds in the shape of a bladder and seeded donors' cells into it. During 2002 and 2003, Thomas Boland developed a new inkjet bioprinting technology in which cells were characterized by their high cell viability. He then patented the same. A year later, the first tissue was directly printed without any scaffold. This episode led to the invention of a new 3D bioprinting technology. The following years saw the introduction of many new bioprinting products. Organovo developed the first scaffold-free vascular constructs in 2009. By 2010, skin printing and injection of hepatocytes into collagen were made possible. In 2012, the first articular cartilage and artificial liver were developed. By 2014, tissue integration with the circulatory system was also effectively achieved. In 2015, a Swedish company named Cellink presented its 3D desktop bioprinter named Incredible. Cellink focused on making bioprinting simpler for researchers at an entry level, and this significantly drove customer adoption during the early stages of the company. By 2016, Daniel Kelly's lab announced its first 3D bioprinted bone. Next big innovation labs in 2018 launched Trivima, India's first customizable 3D bioprinter, and is now set to launch InnoSkin, a bioprinted human skin, by the end of 2020. The last few years have regularly witnessed breakthrough inventions and research progression in both the academic and industrial domains. The recent development of bioprinted bionic pancreas at the Warsaw Foundation for Research and Development of Science is worth emphasizing. Bioprinting is no more a science-fictional or illusional concept of interdisciplinary research. Biofabrication of synthetic artificial organs and tissues to fulfill the unmet need is now just a matter of time.